Hey, today we're going to do some review of proving triangles congruent. And we've learned that there's some shortcuts. We don't have to prove everything's congruent. We just have to show 3 congruences. But it is particular about which congruences. So I wanted to recap real quick so we have these 4 under our belt right now that we know how to do. If you have 2 triangles and you're trying to show them congruent, you need to show 3 congruences. In this first example, we call it the side, side, side postulate. It means that in your 2 triangles, you have to show one set of sides is congruent, show another set of sides congruent, and then a third set of sides. Now, these are 2 separate triangles. A lot of times, our 2 triangles are like touching each other. They share a side, or maybe they're overlapping or something like that. Keep that in mind. But you're going to have in your proof 3 congruences. In this next one, it's called side angle side. Notice that it says here that we have the included side. Let me grab my pen, sorry. 2 sides and the included angle. I said that wrong. The included angle. That means the angle between the 2 sides, like where the sides touch. So in this case, I might have this side congruent to this side. That's side. And then this might be my other side. So I do have the 2 sides, but I'd also have to have the included angle, the angle between those 2. So that angle would have to be congruent to that angle as well. That's what side angle side would look like. Angle side angle is the same idea. You have 2 angles and the included side. That means the side that's between the given angles. Maybe this angle is congruent to this angle. And perhaps this angle is congruent to this. And then as long as we have the included side, the side between them, also congruent, then those triangles are congruent by angle side angle. And our 4th one is angle angle side. So this is not the included angle. It's like it goes, here's an angle, here's another angle, and then the side that's not included between them. Something like that. I always think like I'm wrapping around the triangle to get there. All right. Now, before we keep going, I guess my suggestion is go ahead and get out your 4.3 homework worksheet. We're going to do some of those problems together. And that's what this EdPuzzle is going to be. You will, every once in a while, I'll ask you to fill in a blank on a proof, and then you'll answer your question within the EdPuzzle. Probably go ahead and write it on your paper as well. When it's all said and done, we're going to do several on your worksheet with you or together, and then whatever we don't do will be your homework. All right, let's keep moving. We're going to start with number 1, and you can see there's 2 triangles here. So between, well, really there's 3, but we're going to talk about this left triangle and then the right triangle, and we're going to try to get 3 congruences. As soon as I have the 3 congruences, then I'm going to have my triangles congruent. Let's start off. We always want to put our given in first. There's quite a bit of given. Take a minute and write this down. So segment BD bisects angle ABC. That's given. Maybe if you write smaller than me, you might be able to fit a couple of these in here. AC is perpendicular to BD. Some of you number your proofs. That's nice. Some of you like draw a line between each step. That's nice. Some of you just write neatly, and that's okay too. It's those of you that maybe are sloppy that need to do the line or the numbering on it. All right. Now, what's unfortunate is they have not given us any congruences within that given information, but they've given us something there to work with to create congruences. Now, I should have said this earlier also. You might want to pause the video. You need to go get your proof. I'm sorry, what was it called? It's that, I want to say yellow worksheet, but it's probably different every year. So it's the worksheet that has all the theorems on it. I think it's just called Theorems, Postulates, Definitions, or something like that. You want to have that handy because those things are going to be the things that we use to write all of our reasons. Anything on that sheet is fair game for the reasoning on our proof. Okay. Sorry, I came back. I went and got mine. It's definitions, postulates, and theorems. All right, here we go. Once we have that, we want to go through our given, and we want to look and see what that means in the given. So it says segment BD bisects angle ABC. When we look at this, we're looking at BD is bisecting an angle. An angle bisector is going to create two equal angle measurements. BD is this line down the middle here, or segment, and it's bisecting the angle ABC. So if this big angle ABC is getting bisected, then that means that these two angles up here would end up being equal to one another, or we would call them congruent. All right, let's write it. So angle ABD, remember you wrap around the angle, is congruent to angle CBD. And then we have to come up with this reason. Well, think about where you got this information. You got it because of this given right here. And they use this word bisects. And so that's what it means to bisect. And if you're talking about that's what it means, then that is called the definition of a bisector. Now we might call it definition of an angle bisector or definition of a segment bisector. It can be either. I usually just shortcut it and call it definition of bisect. Or bisector, whatever you want to write there. Okay, got it. Looky, we got a congruence. That's awesome. All right, the next one. All right, we have our next piece of given is this perpendicular thing. And it says that AC, this baseline right here, is perpendicular to BD. All right, somehow we've got to take that and turn that into a congruence. Remember, we need 3 congruences. I'm going to peek at my definitions, postulates, theorems handout. Are you peeking at yours? I'm looking for something that talks about perpendicular. So if you scroll down, the third thing says the definition of perpendicular. 2 lines are perpendicular if and only if they form a right angle. All right, so I could say they form this right angle. The problem is that still doesn't say congruent. So let's keep looking. Okay, I'm looking down. Are you looking? Are you looking? All right, I'm like 3 or 4 up from the bottom. And it says all right angles are congruent. Well, that's what we want. We want them to be congruent. I think this is 2 steps in here. And that makes it a little bit trickier because it wasn't quite as straightforward. I'm trying to do some of the hard ones. You'll have some harder ones. You'll have some easier ones. So right here, this is going to be a 2-step to get a congruence out of this. The first thing I'm going to do is use that definition of perpendicular. And the definition of perpendicular, I just make like perpendicular lines like that. Definition of perpendicular says 2 lines are perpendicular if and only if they form a right angle. Well, I already know they're perpendicular. I'm trying to show their right angles. So what's a right angle? You really could pick either. It wouldn't matter. Well, let's go ahead and I take that back. Let's go ahead and write both of them so that we're on the safe side. This would be a right angle and this would be a right angle because perpendicular lines form right angles. So I'm going to say angle ADB and angle CDB are right angles. That's what the definition of perpendicular says. If you have perpendicular lines, they form right angles. Got it. If you have right angles, then what do you know about them? And this goes back to the bottom of your sheet. All right angles are congruent. Oh, all right. I just said that these 2 angles are right angles. That must mean they are congruent. Angle ADB congruent to angle CDB. The reason? Let's just write it. All right angles congruent. Look, that's a second congruence. I'm down. Okay, and so what that is it's this right angle here with this right angle. So I have 2 angle congruences now. It's either going to be angle side, because that would be 2 angles, or it could be angle side angle. That also uses 2 angles. I've used up the given. What's one last piece that I could use? What do you notice about these two triangles? Are you saying that they share a side? Oh, they do share a side. They both use side BD. And it doesn't matter if you're in the left triangle or in the right triangle, BD is the same length. This is that step where we say segment BD is congruent to segment BD. And I'm thinking BD in the left triangle is congruent to BD in the right triangle. And we call that, it seems weird to say that, but when they're in separate triangles, we have to like clarify that. And that's that reason, if you'll remember from way back, we call that reflexive. When you have the exact same thing on both sides of your congruent sign, BD and BD, that's a reflexive. I think of it like a reflection. You got the same thing on both sides. Reflexive property. And that, ladies and gentlemen, is our third congruence. And that would be this side right here that they share. Now, when you look at that side, is it the included side, like up here, would it be angle, side angle? Or is it like I always say the side that's kind of around the corner? Like you go angle, angle, and then you hit a side. Which of those do you think it is? Answer in the EdPuzzle. All right, hopefully you saw that side as being the included side between your two angles. So our reason is going to be angle, side, angle. Your statement is going to be what you're trying to prove. Your last statement is always your prove statement. So triangle ABD is congruent to triangle CBD. That's kind of a long proof, isn't it? All right, mine's kind of messy. I should probably draw lines or something to clarify which statements go with which reasons. Or maybe I should be numbering. How neat is yours? All right, that's kind of a tricky one, not going to lie. Let's try another one. Here's our next problem, number 2. Let's go ahead and start off. What do you think our first step should be? First statement, I should say. All right, hopefully you realize we always start with our given. I'm going to say EF is parallel to HG. Squeeze this all into one line here. EF is also congruent to HG. All right, given. Never leave a proof blank. Always get those 2 steps in. All right, next thing. Notice we have one congruence out of that. Got it. Let's mark it in the picture. EF is congruent to HG. Got it. We have our one congruence. We also happen to have parallel lines. I'm going to put a little triangle there so we keep track of those are the parallel lines. Got it. Congruent and parallel. We need 2 more congruences. Now, when you look at this,
what do you think we should do?
I was going to go ahead and go with the
next
given.
step.
And remember that
answer
the
in the
order
EdPuzzle.
that you do your steps can vary a little bit. Hopefully, I'm wondering what would you do next? A couple
You
options.
pick. What do you think
I don't
you
know
would
what you
do
marked.
next?
But really, I had a couple options there for you. You might have seen the reflexive step. Do you see that the 2 triangles here that you have share this side right here? They both have that. Okay, so we definitely could do a reflexive step. That would have been a good answer. But the order we do our steps can vary. So if you instead chose, well, we have parallel lines cut by a transversal, probably got some alternate interior angles congruent. So you might have chosen that. Both of those would have been correct answers. So I'm going to go ahead, I guess I'm going to do the reflexive step because it's quick and easy. So the side that they both have is the EG. So I'm going to say EG is congruent to EG. That's because of reflexive. And that, ladies and gentlemen, is a second congruence. Now, looking for our third congruence must come from our given. And what we didn't use yet is those parallel lines. So I want you to look at these parallel lines. And what I'm going to do, I know I have them marked, but I kind of always like to make them stand out. Here's a line, it's parallel to this line, and then I've got this transversal coming through here, because not every option here for angles is going to be correct. You have to pay attention to which angles got created by your parallel lines. And if you'll notice, that would not be angle 4 here. Do you see that? I didn't highlight this side. This is not a parallel side. This 4 isn't really even created by my yellow lines. I am not going to use 4. What other angle am I not going to use? Go to the EdPuzzle. All right, answer should have been 2. You're not going to use angle 2 because this line is not highlighted, so I'm not using that. So I know I have to use angle 1 and 3. If you look at angle 1 and 3, you got parallel lines cut by a transversal. What kind of angles are 1 and 3? Answer in the EdPuzzle. All right, let's go ahead and finish out this proof then. We should be saying angle 1, let me get my pen back. Angle 1 is going to be congruent to angle 3. I can mark that in my picture if I would like. Oh, I didn't mark my reflexive. I could do that also. Now, the 1 and 3, why are they congruent? You can't just say alternate interior angles. That's not a theorem. You're going to your definition, postulate, theorems worksheet, and you're going to flip it to the back, and it's those top 4 options up there. Remember that these work both straightforward, but their converses also work. But you have to look at what you knew. We knew the parallel lines, so I'd say, right here's the parallel lines. If there are parallel lines, then these angles are congruent. That's the theorem, that's the one we want. If you have parallel lines, then alt interior angles are congruent. And that's our third congruence. If you'll look at the types of congruences you have, this should always help you, that you have segments, you have angles. So there's 2 S's and an A. I guess you have to decide which one of these, which method do you think we should use to solve these triangles congruent? Which 3 congruences would we have? Answer in the EdPuzzle. All right, your very last step, triangle EFG, congruent to triangle GHE, and hopefully you said side, angle, side. The angle is the included side. This angle here is included between your congruent sides. It's in between there. It's where those two, it's the angle those 2 sides create. Side, angle, side. There you go. That was a little shorter proof. All right, I got one more for you. This is number 3. We're just kind of working on the front page of your homework sheet there. So let's go ahead and start with our given. J is midpoint of, oh, it's midpoint of 2 things. That's not a congruence. But it might create, it probably is going to create some sort of congruence, and it might create 2 congruences since it's the midpoint of 2 things. Let's see what we got. J is the midpoint of ML. J is the midpoint of ML. Well, remember the midpoint, it's in the middle, and it's going to create these 2 pieces that are going to be congruent to one another because it lands at the midpoint. I know that this and this should be congruent to one another. Let's write it. MJ is congruent to JL. And why do we know those are congruent? Well, because it's a midpoint. And anytime well, because that's what it is. Remember, that's a definition. So that's going to be definition midpoint. Now it's your turn. What do you think the next step of the proof should be? Answer in the EdPuzzle. All right, let's look at what we've got. Hopefully you're filling out your paper also, right? Are you filling out the proofs on paper as we go? Don't just do the EdPuzzle. Don't just let me do it all. You should be practicing writing it, getting used to how those steps work. I'm going to use the other part of my given. I said J is the midpoint of ML. J is also the midpoint of IK. If it's the midpoint of this segment, then this chunk and this chunk should be equal to one another. Ideally, you said segment IJ congruent to segment JK. And why? Definition midpoint again. We have two congruences. They're both sides. All right. I need something else, and I've used up the given. So if you've used up the given and you still need some congruence, then it's got to come from the picture. So look at your picture. Is there anything that you know is congruent from your picture? Go ahead and answer in the EdPuzzle. All right, hopefully you recognize, oh, we've got vertical angles here. It's not a reflexive. This triangle here is totally separate. I know it touches right here at this spot, but these two triangles don't share a side. They don't share an angle. What they do create are these vertical angles here. And we know from a theorem is that vertical angles are congruent. So I'm going to go ahead and mark. I know that this angle is going to be congruent to this angle. Let's go write it. Angle. Got to use 3 letters because you can't just call it angle J. There's too much going on at J. So angle IJM congruent to angle LJK. What's your reason? Write it, but also answer in the EdPuzzle. Our theorem just states that vertical angles are congruent. That's a third congruence. Let's write our last statement here. So we've got our triangles congruent by triangle MJI congruent to triangle LJK. And this is your last EdPuzzle question on this. Why do you think we can prove these triangles congruent? I see that I have 3 congruences. Look at your 3 congruences. And then decide, and look at your picture, I guess. If you look at just this triangle here, what do you have going on? Which method would you use? Answer in the EdPuzzle. You have 2 sides and an angle. So I know I have to have 2 S's and an A. If I look at that angle, it's the included angle between the 2 sides. It's where the 2 sides meet. So we would be going side, angle, side. That's it. Now, that's the front page. If you flip to the back page of your homework, these I want you to do on your own. I'm actually going to do number 7 as a bonus. If you want to go through number 7 with me, you can do that. And then you don't have to do it for your homework. You can choose just not to do it and not get bonus for it. Your homework is to finish the rest of this worksheet, except for number 7. Here it is. What's different about this one, what's a little bit tricky, is the 2 triangles. Because not only, they don't really, they're not like touching, well, they are touching, I don't know. I guess maybe we should first look at which triangles, because there's a mess of stuff going on here. I see it in my head, but that's because I look at these kind of things all the time. Let's look at our 2 triangles. Prove triangle GFE, this one right here, is congruent to triangle DEF. Okie doke. Now, what I'd like you to do is perhaps consider looking at these 2 triangles separately. I think sometimes when you have overlapping triangles like this, look at them entirely separately. That was an idea. Can I try that again? I don't know. It's this one, because that's a kind of a vertical. There's that one. And then you have the red one that looks like this. And I'm just going to kind of separate those so you see, all right, those are the 2 triangles we're trying to prove congruent. Is there, I guess let's go ahead and put the given in on your proof. angle G, GFE congruent to angle DEF. That's given. That's a congruence. That's helpful. Oh, and they gave us another congruence. GF is congruent to DF. That's given. You could write given again or just draw your line so we know it's all given. Okay. You've got a segment and you've got an angle. That's two things right off the bat. I'm gonna mark, they marked the picture nicely, but I'm gonna mark it on my separated triangles. So one of the things was this outer leg here and this outer leg up here. Those are congruent. The other thing that's congruent is this angle. It's this big wide angle right here and this big wide angle up here. The last thing we need, I guess, is one more congruence. Can you look at these two pictures and think about what congruence would you be using? What would your reason be? Answer in the EdPuzzle. Now, this is a little bit trickier because the triangles overlap. You're looking at what side they'd have the same. And ultimately, that is this side here and this side here. Those two sides land on top of each other in the triangles right here. So FE in the blue triangle is the same as FE in the red triangle. That segment does not change its length. So I'm going to go ahead and put FE, oops, it changed colors on me, sorry, congruent to FE, and our reason. Okay, whenever they share a side, you got the same thing on both sides. That's reflexive property. And that's your third congruence. And if you look at your two triangles that you have pull away separate, can you tell me which method would you use to prove these triangles congruent? All right, you got two sides, you got an angle, so it should have been side, angle, side. You can see that the angle is tucked in between the two sides. Go ahead and put your triangle info in there. Triangle GPE congruent to triangle DEF. And our reason, side, angle, side. All right, thanks for sticking with me on that one. That one was a little bit tricky because of the overlapping triangles like that. If you want to just go ahead and finish up the rest of your worksheet. Thanks. Bye.